this is the bit where you have extensive experience with this. My experience is a bit more on the toy level, where effectively the farthest I've gotten with most of these things is essentially embedded analytics in the dashboard, and deploying those to make sure that they're good enough. But as far as saying things like, okay, rigorously, how do I test that these things work in all scenarios? How do I deal with the different software outputs, things like that? Beyond basic, creating little distributions, testing input versus output type of things in scenarios like that. A little bit of model tracking, like if, for example, just seeing if in different segments over time, your model's having drift, or there's feature drift, or there's drift like that. And of course, I get to create cool dashboards like that and play around with the machine learning bits on that. But formally, for someone who's actually good at it, unlike myself, what is the process in that? Because I think that's sort of where you're trying to really spearhead.
Definitely. I mean, first of all, when you describe my experience as this is extensive, I mean, it's definitely been my focus for the last good number of years now. But one of the most exciting parts of this aspect of the kind of data science development process and software more generally is that this is also new, and there's so much still to be defined from certainly from a best practices perspective. Now, there's a few best in class companies that certainly have processes that I've actually largely been kind of, say for a few notable examples, that they're kind of largely obfuscated from the discipline more broadly. So the ones that jump out are these kind of large, kind of FANG companies. So Google's the kind of canonical example for an organization that's able to productionize kind of machine learning at scale and doing that while delivering kind of product value. And there's obviously other teams like Apple and Uber and Facebook who were doing similar things as well. And there'll be more domain-specific examples, but to me, those are the teams that kind of have the most kind of operational experience behind doing this. But there's not as much kind of broad agreement across the industry as to how, even just the question as to how we move from that kind of proof of concept stage where we have a model or a feature or something that's been analysed and experimented upon and developed in collaboration with stakeholders in the organisation, and there's a clear product need for it. But even just the movement of that towards a production scenario is something that there's a flurry of activity at the minute, and has been for the last, I would say, 18 months to 2 years, from a kind of software practice perspective. And I'm not really sure what the reason for that is. I think maybe the prevalence of tools from a compute perspective and from a data availability perspective they've certainly reached there seems to have been some kind of action potential we've got past over the last 5 years, where things that were previously exceptionally difficult are now becoming, from a data engineering perspective, are now becoming much more tractable and much more commoditized. So historically, if you give a specific technological example, there's a tool that I've been using on and off for the previous, since 2014, so I don't know how many years that is, so it's 7 years. Called Spark, which many data scientists who are working in teams will be familiar with. Mm-hmm. When I began using that, it was it's been an Apache project for I think since the outset, but it was very difficult to use to begin with. It's something that took a lot of development of kind of very specific skills and understanding to make the tool work to do in-memory data shaping and analysis and some machine learning if you were interested in that aspect of it. So back then, there was a lot of kind of investment to make that work, and then the operational stuff behind the scenes to make it part of your software stack was very. You had to put a lot of investment and time into that as well, with multiple kind of software experts contributing to it. Not just the actual data science output of that becomes maybe a data pipeline thing, but in the running of the cluster behind the scenes to make sure that works correctly and is available for data scientists to use as a tool. But nowadays, because of tools like Databricks, this is now a managed service that you pay for and you get access to, as your team will get given the keys basically to do all the cluster computing that you would want. So this has meant that teams are able to get spun up doing this kind of stuff that historically, even as little as 5 years ago, was really difficult to orchestrate, but is now much more accessible and can be spun up a lot more quickly than it previously had. So that's one explanation as to why this is becoming more of a kind of topic of conversation now that we've got the compute and the process to deliver these data science or machine learning assets to the point where we want to put them in our products more widely. It's become much more a commoditized thing that smaller teams can do that. But the challenge with software is always, it's not necessarily making the thing work in the first instance. It's not a case of proving that your approach works. And this also applies to just traditional software as well, not necessarily data science focused stuff. But it's what happens when you put that out into the production system and how that piece of software exists from a continuous development process. There's a whole area where software developers will talk in depth called continuous integration. Basically, practices for making sure that if there's multiple developers working on the same project, that those contributions can live with each other from like just to make sure things don't break perspective, but then also to make sure quality remains high as well. Taking like something that's as simple as like a change to an API is not as a non-trivial thing to orchestrate from the actual software delivery perspective. And it makes sense that doing this for data science is really difficult too. So now there's a whole host of startups and companies who are looking at, the kind of broad term for it is looking at, they refer to it as machine learning operations. So now we've got the data science value, we've got the stakeholder buy-in, our model works, great. What next? We move it towards production. And it's not just an overnight thing that we decide, okay, well, to Monday morning, we'll just drag and drop the the model file to this new directory somewhere, and then we deliver predictions, and that's the end of the story. Like this ongoing process is like it's a new kind of, in many ways, it's a new kind of software that we're having to learn how to operationally support and develop upon, and kind of work with as a component in production systems. And it's almost every day there's new people. There's people writing new materials about how they are trying to approach the problem, how they think approach Y is better than approach X. So there's a huge flurry of activity in this area. So to describe it as my experience has been extensive, I've certainly been thinking about this a long time, but like this is all very new to almost everybody, except those who've been delivering kind of high scale machine learning at the scale of a Google or one of those large companies for the past however many years they've been doing that. So to be honest, like there's two sides of the coin here, where it's really challenging, but it's also very exciting to think about this in any kind of depth. I think the main thing that I try and proceed with forward is, at the end of the day, if you're delivering something that's going to be product focused and is working in a production system, at the end of the day, it's all software, and there's practices that we have for software that isn't relying on empirical processes to develop, like machine learning models, for example, are. And we can begin to look at how we do this for conventional software and try and apply it to those more empirically defined pieces that are so kind of characteristic of the data science development process. And that, just saying that is not easy. Like this stuff is really difficult to do. It's just it's almost like, it's not like the kind of addendum to the data science process where, it's like there's a single step that we then see, and then we put it in production and everything lived happily ever after. Like in my view, I think this is where almost a whole new discipline is going to develop over the next 5 to 10 years. And it's only now we're starting to see kind of people looking at this in earnest. And there's loads of really, really interesting and cool technologies that people are building, purpose-built for this kind of stuff, from the model orchestration to serving to instrumenting. Like you were mentioning there was, I think, Glenn, you mentioned like 5 or 6 different things there, from like a serving and instrumentation and testing perspective. And these things are like, these all make intuitive sense for us to talk about from a quality perspective, but the tooling just now doesn't really exist for many of them, which is scary, but it's also really exciting as well.